So friends, very good morning. In this video, we will learn about the section of a square pyramid which is resting on its base on HP and that is being cut by a section plane which is normal to VP and inclined to HP. And let's see what is the question in store for today's video. A square pyramid of side 20 mm and height 65 mm resting on its base on HP. So friend, this is a square pyramid and it has got a side measuring 40 mm and the height measured from the vertex to the center of the base is 65 mm. Is cut by a section plane which is normal to VP and inclined to HP as I told before, such that the true shape of the section is a trapezium having side 40 mm and 20 mm. Friend, before we position the object initially, let us see what happens to the section if it is being cut by different section planes. Please listen carefully. Suppose you have a square pyramid resting on its base on HP, and if it is cut by a section plane which is perpendicular to VP, means perpendicular to the board and inclined to HP, the inclination of the cutting plane or the section plane to HP can be seen only in the plane view as a line. For example, friends, here they have not specified how the object is to be placed, but it is said if you are cutting it when it is placed on HP on its base, the true shape should become a trapezium. Friends, for your kind information, a trapezium is a figure which will have parallel sides. One side will measure 20, other will measure 40, and they have not given what is the distance between these two. Now friends, let us take one or two simple cases of this square pyramid. For example, friends, if it is cut by a horizontal section plane, a plane perpendicular to VP, if it is cut by the section plane, the true shape of the section is going to be a square. The square will have a dimension in the decreasing order in the true shape when you move towards the vertex. And when you move towards the base, the true shape is going to be a square only, but it will have a higher dimension compared to when you are moving above. So friends, whether a square pyramid you have got, a pentagonal pyramid you have got, whatever may be the type of pyramid, whenever it is cut by a horizontal section plane, the true shape is going to be the true shape similar to that of the base. If it is a hexagon, in the true shape you are going to get a hexagon. Now friends, if you are cutting this by a section plane such that the true shape should be a trapezium, that is cut by a section plane, true shape should become. So friends, if you are holding like this and if you are cutting at an angle, it is going to cut this portion and also this portion, these two edges at a height and these two edges at a height from the base. So you are going to have 4 points and these two edges where the section plane is cutting like this will be parallel to each other. So to obtain the true shape a trapezium, it is very essential to keep the solid on HP with one of the sides normal to VP. Say this side is perpendicular to VP. So that is how we decide how the object is going to be placed. And generally the questions on square pyramid are very important from the viewpoint of examination also. Friends, have placed the pyramid on HP with one of the side parallel to VP or one of the side perpendicular to VP, and we have marked the height of the solid that is given as 65 mm. So the height I have taken as 65 mm and I have drawn this front view on top view. The vertex is O dash, and we have here, friends, the other points of the base, namely, so we will call it as A, B, C, D, A, B, C, and D. And this will have a dimension of 40 mm. Yes, 40 millimeter is that. So we have this 40 mm and the height is given as 60 mm. You have marked A, B, C, D. Let us transfer all these points of the base to the front view. Say this is going to be A dash, B dash, and this is O1 dash. This is going to be C dash, D dash. So this is O dash. Friend, this point is O comma O1. O represents the vertex and O1 represents the center of the base. Now friend, if you are cutting this by a section plane, say some section plane like this. So here if you are cutting like this, you will get some 2 points here, 2 points here. So on this you will be getting that line, section plane, where it is cutting these two edges. But the dimensions of that should be 40 by 20. That means the section plane should pass through this base so as to get the dimension 40. If it were 30, I would have taken somewhere here. If it is 20, somewhere here. So since it has to have a dimension of 40 by 20, this should be one of the endpoints of the cutting plane or the section plane. So friends, I can just mark a point here and the other point here, where the section plane is passing through the base edges A and B. Friends, on the same line, it has to cut somewhere here. So somewhere here means what? That should have a dimension 20. So what I do, friends, I'll write a horizontal line through this. Mark 10 mm above and 10 mm below. Somewhere here. And transfer that to these 2 points, these 2 edges, OD and OC. OD and OC should have a width is equal to 20. Friends, they are cutting here. So we can simply transfer that to the front view by drawing a vertical line from there. And this is going to be the second point where the slant edges OC and OD are cut by the section plane. Friends, you can join these two by the section plane. You can mark it as SS. SS is the section plane which is cutting the solid. And here friends, this is the base of the solid that is not touched, and this is the other portion. And friends, this view below the section plane, so you have to show these lines by thin lines, but this has to be darkened, friends. So this will give you the front view of the solid. And this, friends, you have got two points here and two here. We'll call them as 1, 2, 3, 4. So I will say I will mark 1 here. This is 2. This is 3 in order. And this is going to be point 4. So let us transfer these points 3 and 4 here. And friends, here, if you are join them, join all those 4 points by these straight lines. And friends, you are going to get the top view in section, which is called the sectional top view, like this. And friends, after that you have to darken the remaining portion of the base of the solid. So I am going to join like this. And remember, this portion of the slant edges should also be darkened. So we have got the front view here, friends. We have got the sectional top view, since there is hatching. And now with this information, you can find out what is the angle made by the section plane. That will call it as theta with the horizontal plane. So theta can be found out. So in the question is asking you the inclination of the section plane. SP means section plane with the HP. Yes, that is theta. We can find out. Next, the distance between the parallels, that will also have it later on. Then friends, now after getting the front view and sectional top view, We are also asked to find out the sectional end view of the solid. Friends, to obtain the sectional end view, we have to obtain the end view. See friends, in case of a square pyramid, the front view and the end view will have similar triangles. That is isosceles triangle. So I'll mark this as O double dash and this point as AD. If you transfer them, this is going to be A double dash, D double dash. This is O1 double dash. This is B double dash, C double dash. Now friends, we have to transfer these points 1, 2, 3 and 4 onto the end view to obtain the sectional end view or left sectional end view. Friends, points 1 and 2 are here. 1 at A, so we call it as point 1. 2 at B, that point is here. We will call it as 2. Then we have got 3 and 4. So we have to have that 45-degree line here and transfer them onto that. So this is 3 and 4. So one will be on this, one will be on the other end. So we are going to have these 4 points. Friends, what are they? So here we can have a better line. Okay, see, we are getting like this. So friends, we are going to have 4 points totally. 1 at A, 2 at B, on OC it is 3, on O4 it is 4. So this line is going to be parallel to the base. Join that to 1, 3 to 2, and this is how the sectional end view of the square pyramid looks. So we'll call this as LSEV, left sectional end view or sectional end view. So this is how we are going to get, friends. To tell you correctly, it has to come exactly here, we'll mark there. So it's going to be exactly like this. This is 3 and 4. This point is 3 and this is 4. So in the left hand view, you are going to have the section like this 1, 2, 3, 4. This is the sectional top view and this is the front view. And friends, so add an end view that we have done. Obtain the true shape of the section. Friends, you know very well, to obtain the true shape of the section, we have to draw a line parallel to the section plane anywhere convenient to us. Suppose you have got the section plane here. I am going to draw a line parallel to this section plane. Say something like this. So you should write it parallel to the section plane anywhere. So this line is parallel to SS and we have to transfer all these points. Point 1, 2, 3 and 4. So we have to draw one more set of what you call the perpendicular lines from here. One line from here and another line from here. Friends, these two lines we are drawing are normal to this S1, S1 or something like say X1, Y1, some reference line. So friends, on this you have got 1 and 2. So 1 is to be marked here and you know these two lines are perpendicular to each other. And here friends, 1 is at a distance of this much. From xy to this, you get the point A. Sorry, it is point 1. Next, 2 is here at this distance. Very obviously, AB will be equal to 40. So I can take another point here. That point is 2 and that is going to have a length is equal to 40 mm. As it is very obvious from the top view, you can see that. Friend, this is point 1, this is point 2 I have marked. Then I should get 3. 3 means distance from xy to this is 3. So it is going to be somewhere here. And 4 is the distance of 4 from here to here has to be taken and marked on this. And friends, this is 1, 2, 3 and 4. They come in order. So 3 is away. 1, 2. 1 is nearer, 2 is away, 3 is away, 4 is near. Okay. Okay, these are the 4 points you get. We will join all these points by straight line to obtain the true shape of the section. Friends, remember the true shape of the section is a trapezium they have given, and this distance is going to be very obviously 20 mm. That you can verify from the top view. Distance between 3 and 4 is 20, and that's between A and B or 1 and 2 is 40. Friends, after getting this true shape, let us hatch this or section this by drawing lines at an angle of 45 degrees to the horizontal like this. Equally spaced lines will have like this, and this will give you the true shape, and this true shape is a trapezium. Trapezium. And what is this last, friends? The inclination of the section plane we have got the distance between the parallel sides of the trapezium. This is the trapezium you have got. The distance between them is this distance, which is exactly equal to this. So I can easily measure what is the distance between these two lines. So this can be found out, and that will give you the distance between the parallel ends of the trapezium of the true shape of the section. Next one, add an NU. NU you have got already, and obtain the true shape you have got it. Friends, this is how we obtain the front view, sectional top view, sectional end view, and true shape of the section. When the section and its object is cut by a section plane inclined to HP and perpendicular to VP. Friends, I am very sure that all of you would have followed clearly the instructions given for solving this problem on the section of a square pyramid. And friends, if you are happy with the presentation I have made, please subscribe to this channel only if you like it. And if you like this video, share this video with all your friends without fail, and have a blessed day. I thank you very much for watching my YouTube video.